Hey everyone, welcome to the 15th episode of the Coffee with Cosmos DB series. If you have missed to join the last session, you can watch the recording in our playlist. If you would like to know more about a particular topic or a feature, please ask in the chat so that we can take it up in the upcoming sessions and discuss here. Uh, yeah, if you're joining this for the first time, this series is all about spreading the knowledge on Cosmos DB by the experts to the community. So please make sure to subscribe the channel and share with the community members who are looking to learn more about Azure Cosmos DB. If you are willing to present or have any feedback, please reach out to me. And thanks for all the feedback so far. You can also use the hashtag coffee with Azure Cosmos DB if you have any feedbacks. With that, let me introduce our guest for today. Today we have a guest who is someone closely working with customers. One of my favorite champion when it comes to Cosmos DB. Um, Let me introduce RK. I call him RK. Probably I will let him to introduce himself. Hi RK, how are you doing?
Hey, hi Saji. Thanks for having me here. Hello
Yep.
everyone. I'm
Yeah.
RK Iyer.
Yep. Go ahead. So
Hey, hello everyone. I'm RK Iyer. I work as a cloud solution architect. I'm based out of Singapore. I help the customers build data and AI solutions on Azure.
yeah, today I think we will be talking about one of the interesting topic, right, which is real-time analytics with Azure Cosmos DB. I think you will be covering some of the um, important concepts and also the use cases. Without a further delay, let's get started, RK. Yep.
Yeah. Thanks, Saji. So today I would be talking about Azure Synapse Link for Cosmos DB. So let's quickly look at the agenda. We'll start off with understanding the HTAP pattern, which is the emerging pattern. The next is to understand about the Cosmos DB analytical store, which is a key component for Cosmos DB Synapse Link. Next, we'll understand about the different use case patterns and the billing for Azure Synapse Link for Cosmos DB. And last, we have the demo. So let's quickly get started. So, understanding the different business application patterns. So, you would be aware of OLTP pattern, which is online transaction processing system, wherein you have your different web application and mobile application working with the transactional data. And typically, we see CRUD operations being performed on different RDBMS and NoSQL databases. Then we have OLAP, which is online analytical processing system, wherein the data from the OLTP systems are loaded into the OLAP system using ETL. And here we have different long running analytical queries to perform different aggregation and come up with different dashboards. And now we have the latest emerging HTAP, which is hybrid transaction analytical processing, which breaks the wall between the OLTP and OLAP. It enables real-time business decision making. So now let's understand the traditional approach for analytics before HTAP. So as you can see in your screen, we have Cosmos DB wherein all the transactional data gets stored. We have an orchestrator, which is Azure Data Factory, which is used to retrieve data from Cosmos DB and push it periodically to data lake. Azure Data Factory also invokes the parallel compute in form of data bricks to transform, standardize, and aggregate this data so that it can be used in a consumable form and then again pushed back to Cosmos DB or any other RDBMS from where different apps and dashboard can look up. So if you look at the limitation of this approach, we have three main limitations. One is the performance and cost impact. So when we read from the Cosmos DB, we have to spend extra RUs, which is rate-based currency for Cosmos DB. And again, the performance for Cosmos DB also get affected. The second key limitation is the delayed insight. So if you use orchestrator like Azure Data Factory, it's not real time processing, but again, it's near real time or batch processing, wherein you can have your jobs every 15 minutes or hourly or daily basis. That's where you have delayed insight of on the data. And the last limitation is that the data format and storage needs to be managed. Even we need to manage the ETL. So these are some of the limitations for the traditional approach, and that's where HTAP came into picture. So now let's look at how Synapse Link for Cosmos DB works. So as you can see, we have the transactional store wherein the data from different application pushes the data. And here we use the row store format, which is optimized for transactional operation and for getting sub-second, millisecond latency. This data get automatically synced to analytical store. So the data in analytical store is stored in a columnar store, which is a good fit for all analytical queries. And once this data is stored in analytical store, we have Azure Synapse Link, which forms a link or a bridge between Azure Synapse Analytics and Azure Cosmos DB. And you can use different analytics, Synapse Analytical tool like SQL Pool or Spark Pool to query on the analytical store. And if you look at the advantages of this pattern, we have no RUs for syncing the data from the transactional store to the analytical store. Again, when the data is stored in the analytical store, it is compressed. We have seen around 70 to 90% compression on the transactional data in the analytical store. So your storage also gets cheaper. And the third advantage is when you query your analytical store using Synapse Analytics, there are no RUs charged for that. So now let's deep dive at the analytical store design and some of the key features. So if you look at how the data between the transactional store and analytical store gets synced, it gets auto synced, and this happens within 2 minutes. The reason why we don't have real time, but we have near real time is, as you would be aware, that Hadoop or any big data framework is not efficient for large number of small files. That's where all these small files or all these small documents or small number of inserts, updates are batched together and pushed into the analytical store within 2 minutes. The next feature is we always get the latest version of data. So whatever is the latest version of transactional store, we always get the same version, which means if you insert or update your data, that gets synced in the analytical store. Another feature is that it's self-managed compute. You don't need any ETL. Again, you don't have the disadvantage that your transactional throughput is wasted. And again, there is no downtime for enabling the Synapse link. There are no performance or cost impact on the transactional workloads because behind the scene, we use the log store. And that's how the data from the transactional store gets synced to the analytical store. This is the most important point. So there is an automatic schema inference, which means that the data in the analytical store automatically infers the schema from the transactional store. We'll look into it in detail in the next slide. Again, we have native integration with Synapse to analyze the data with Spark and SQL runtimes. And this Synapse operational, the analytical store is available in any global region where you have the Cosmos DB account replicated. So these are some of the key properties or features of analytical store.
Hey, RK, I got a couple of questions. Maybe those are fundamental questions. Like one of the things that you mentioned is that, I mean, from the customer's point of view, right? So if you understand right, customers who use blob storage for their data archival could potentially use this as an option, is it?
Yeah, sure, definitely. So that's one of the use case wherein, if you want to save cost and you want to use the data of transactional
Mhm.
store, you can have TTL on the transactional store and you can enable the Synapse link and you have the data backed up in the analytical store.
Okay, makes sense. Other question is that you talked about Synapse Link, and since Cosmos DB is a multi-model database, right? Uh, I would say, is it supported across all APIs on Cosmos DB?
So currently we have support for Cosmos DB for NoSQL and MongoDB API. And
Mhm.
we have Gremlin API, which is in preview. So that's the support which we have for
All right. Okay. Thanks. Yep.
the APIs.
Yeah. Proceed. Those are the two questions.
Okay. So now when we look at the schema inference, right? So there are two methods for schema inference. The first is well-defined schema, right? Which is the default option for SQL API and Gremlin API. And we have full fidelity, which is the default option for MongoDB. So now let's understand what is well-defined schema. So in well-defined schema, the Synapse link or the analytical store, it first looks at the first document and the data type is decided on the property of the data type where it is first encountered. So let's take an example. So if you see on your screen, you have two records. We have the purchase date, which is highlighted, it's in string format, and we also have the purchase date in an integer format. So in case of well-defined, what would happen is, since the purchase date with string data type has been encountered first, that will be the that will be used as the data type for the purchase date. And if the subsequent property for purchase date, if the data type is integer, it would be null. And now if you look at the full fidelity, as you can see in the bottom of the screen, for the same example, if we have two documents, one with purchase date string and second with purchase date integer, we have a column for each data type with a property. So if you see over here, we have purchase date with string and purchase date with integer. So for the first document, purchase date with string is populated. And for the second document, since the purchase date with string is an integer, the second column is populated. So now if you look at the trade-offs between both of these approach, the first one is the simplicity and the second one is convenience, right? So in case of the first one, as you can see, we have well-defined schema wherein you provide the purchase date with a string, but in case of full fidelity, you can have both the data types in your where clause and you will get both the documents. So I hope you understood the schema awareness for analytical store. Now let's look at the different use case patterns for Synapse Link. So the first one is the most favorite, wherein once you have your Synapse Link enabled and you can use your serverless SQL pool to run analytical T-SQL queries, you can have ad hoc queries on near real-time data. So users who know T-SQL language can fire those queries. And once you have the data, you can even build real-time dashboards using Power BI. Again, we have seen customers who create a logical data warehouse to analyze and have a unified view across different data sources like Cosmos DB, Data Lake Store, and Blob Store. And the fourth is the most interesting use case, wherein Spark ML as well as Azure ML is used to have different machine learning use cases. So these are the different use case patterns which we have seen the customers implement. So now we look at the example wherein we have a use case wherein the customer was not using Synapse Link before. At that time, we had the data from the IoT devices captured in the IoT hub, and then we had stream analytics to process this data and store it in the Azure storage. And once the data is in Azure storage, we had ETL to process this data, push it into SQL database, and we had Power BI for different dashboards. So if you look at this approach doesn't have any monitoring insights or even real-time reporting. Now, this was replaced with Azure Synapse Link. And as you can see on the right-hand side, we have the IoT hub. We still have the stream analytics, which captures and processes the data, and it pushes it into Cosmos DB. And once it pushes it in the Cosmos DB transactional store, we enable the Synapse Link to have near real-time dashboards and reporting. We don't have any ETL, and we can also use Synapse Analytics along with Azure Machine Learning to come up with different trends and real-time reporting.
Okay, there
So
is a
now let's
question on the chat. Sorry to
okay,
interrupt.
sure.
Let me show it on the screen. Uh, is Analytical Store supported in all Azure Cosmos DB regions?
Yes. So analytical store is supported cos on all Cosmos DB regions. Yeah, in all Azure
Okay,
regions, in fact.
all right. Yeah, and other question I had is like, okay, you can proceed. Maybe we can take it at the end. Yep.
Sure. So now if you look at the different pricing options which we have, right? So again, there are three main components for Azure Synapse Link. The first one is the storage, right? Wherein we have the data retained in the analytical store. Then we have the different write operations and read operations on analytical store, wherein we charge $0.05 per thousand write operations and $0.005 for 10,000 read analytical storage operations. So one of the key recommendation is to use Cosmos DB capacity planner and calculator to get an estimate of analytical storage, read and write operation cost. One more thing which is highly recommended is to use or is to do a POC to get finer level estimates for the read operations, because again, read operations depend on different use case, right? There could be ad hoc reads as well. So again, it is highly dependent on the use case, and that's where these are the two key recommendations: to use the capacity planner as well as to do a POC before estimating and coming up with the pricing. Yeah. So I'll just take a quick pause. And Saji, do you have any questions? Or we can go with the demo and then.
Yeah, right now there are no questions on the chat. You can proceed with the demo. I will ask as they come up. Yeah.
Absolutely. Thank you. Thanks. So now let's look at the demo. So we have a retail scenario, and this is a fictitious scenario wherein we have data coming from different online shoppers. So as you can see, we have different, we have a retail store which has online as well as offline mode, wherein the users can use the online medium or they can visit the store and they can do the purchase. So we had two key asks. The first one is that the customer was setting up a business analyst team who would want to do data exploration, and they were familiar with ad hoc querying. They were familiar with T-SQL queries, and that's where they wanted to do ad hoc querying. So that was the first ask. And the second ask was that for the offline mode, one of the key challenges was to do product sales forecasting. And that's where the distributors wanted to predict how many units are needed in the local warehouse that need to supply to the store for a particular area. And these were the two key asks. So what we did is we had the data in the Cosmos DB transactional store, and we enabled Synapse Link, and we had the analytical store, and we used Synapse SQL Serverless as well as Synapse Spark for helping the customer to solve both of these challenges. So now let's look at the demo. Saji, can you confirm if you are able to see my screen, please?
Sorry, I was on mute. Yes, I can see it. Yeah.
Thank you. So we can see here we have the Cosmos DB. We are using the NoSQL API, and we have the retail database wherein we have different collections. So we have the customer main wherein we have the customer data. We also have the online sales, which is used for by the online customers. We have the product catalog, the products, the retail sales, wherein we have the sales data, and we also have the store demographics, wherein the demographics for each of the stores are stored over here. So the first thing what we do is to enable the Synapse link, and that's where we go to the Azure Synapse Link blade. And here if you see, we can enable the Azure Synapse Link. So we have enabled the retail database. So all the collections within the retail database have been enabled. So you can select the collections which you need to enable the Synapse link. So once we do that, we go to the, so let me share the Synapse Analytics workspace. And now, once we have enabled the Synapse link, this is where on your left hand side, you can see the different collections which I just showed. And once those have been enabled, you can see a bar chart on the left hand side, which means that those are all Synapse link enabled. And what you can do is you can right click on the collection and you can click on the new SQL script. And once you provide the key, you can use the open row set function, and you can query on the analytical store. So this is how you can query using your T-SQL queries. And for users who are well aware with Spark, what they can do is they can load this in a data frame. So once they have this, they can load it in a data frame and perform different data frame operations and also invoke ML. So now let's look and go back to our scenario wherein we wanted to have a ad hoc query on using the T-SQL. So the first step is to create a credential. So you create the credential and then we can create a database and then we can create views and use the open row set wherein we provide the Cosmos DB account as well as the database name. We provide the object which we have used as a link service, and we also provide the credential. So using this, we create views. So in our case, we have created different views with all the records for retail sales, products, store demographic, product catalog, as well as customer. And once we have done that, what we can do is now we can, once the view is created, we can query it. So it's just a T-SQL query, right? So we are just using a T-SQL query to query on this view. So as you can see, we can query it using T-SQL, and we can also do joins. So in this case, you can not only query, but you can also perform T-SQL operations like join. So in this case, what we have done is we have joined the store demographics along with the sales data. And now we run this query to see if we are able to perform the join operation. Yes, we can perform the join operation wherein we have the data from store demographics as well as the retail sales. And one more thing to note is that we would also have sub objects within a document, right? So in our case, we had the customer, and within that, we had a address sub object, and we had the properties for that. So we can even go and get the values for that. So this is how you can do it. So in this case, we have not only taken the outer properties like first name, last name, district, gender, but we have also gone into the sub object which is address, and within that we have the state, country, as well as the city property. And we can fetch the records and fetch the nested properties. So this is how we can fetch the nested properties. So this is how the business users can perform T-SQL queries on the analytical store, and they don't need to know Spark or any other language. The second problem which we had to solve was to perform a sales forecasting. So this, so here we are using a Spark pool, and we are also leveraging Azure Machine Learning AutoML to do a Microsoft Surface sales forecasting. So we have a product in our store which is Surface, and we are doing a sales forecasting for that. And this will help the distributor predict how many units are needed for the local warehouse. So here we are creating a sales database DB, and we are using the link service to create different tables. And once we have these tables, we are using the Spark SQL to join this data. So now we have joined the retail sales, demographics, as well as the stores data to come up with the data which has all the information regarding to the store's products and the store demographics. And once we have this, now we can leverage the power of Azure machine learning, AutoML. So once we have the data in the data frame, now we are leveraging Azure machine learning. In this case, I have created a separate instance of Azure machine learning. I have provided the details for that. And then we are preparing the data. We are doing feature engineering, splitting the data into the training and the test data set. And once we have that, then we use the AutoML for forecasting. So in this case, it has executed the AutoML and we are retrieving the best model and forecasting. So once we do that, we are then plotting the result. So this is how we can come up with the prediction, and this is how we did the sales forecasting for Surface product. So this is what I had for today, and this is how we have leveraged Azure Synapse Link for Cosmos DB to solve both the problem or both the challenges for the retail customer. So
Yeah, thanks, Arkai. I think that demo was fantastic to showcase the feature as well as some of the capabilities that customers can leverage by combining, other services. I do see like few questions on the chat. Let me sh- show it on the screen. First question is from Scott: whether can I disable or enable the Azure Synapse Link feature whenever I need for my Azure Cosmos DB account? So it's about enabling and disabling the feature.
yeah, so it's not a, you cannot, so you cannot enable or disable it, right? But you can still disable the containers which are there for the analytical store, right? And that action
Mhm.
cannot be undone.
Okay, which means like once it's done at account level, it cannot be disabled. All
Yeah,
right. Okay.
right.
Thanks.
And again, you have like multiple ways, right? You also can have set TTLs for the analytical store, wherein
Hmm.
you can stop your data coming into analytical store by setting the TTL to -1.
Okay, that makes sense. Another question from Scott as well. What about the SLA? Um, I think this is about whether it would impact the transactional operations when we have the Synapse link.
So again, the transactional store SLA are not getting impacted, but in case of operational store, we store it in a separate storage account, which is abstracted from the user. And again, we use LRS for that. And if we have enabled ZRS, you can also have ZRS for that, which means in case of LRS, you are given around 11 nines.
Okay, got it. There is another question from Sonia. It's a long question, so let me read it. In well-defined, if we insert a new row into an empty analytical store and delete the inserted row and then insert a new row, will it recognize the new schema or still follow the original schema from the first insert?
Yeah, so that's a very good question. And yeah, so I believe that it will still go with the original schema. So what it
Okay,
does is the first time it understands the property and it will identify that, and the subsequent property, if the data type is different, it is going to have consider that as null.
all right, okay. Yeah, those are the questions I saw on the chat. If you have any other questions, please post in the chat. We can take it in a minute time. Uh, I had another question basically. Uh, when you say latest version, right? You mentioned about the latest version. Does it take care of all three, like delete, insert, and update operations?
Yes, absolutely. So it takes care of all the three operations. So in fact, if you remember, right, like we also have change feed. Previously, the change feed did not support delete, right? But in this case, it supports all the three operations: insert,
Okay,
update, as well as delete.
all right. Thanks, RK. I think those are the questions that we got from the audience as well as mine. Yeah, I think we are on time as well. Thanks for all the questions, those who watched this session. And also, if you have any further questions, you can just ask in the comment of the video. Once we publish the video, this video will be available after the session ends, so you can ask your questions offline as well. With all that, like we have come to the end of this episode. Before I close, make sure to subscribe the channel, and please do provide the feedback if you want to hear about a particular topic, or if you want to present in this forum about Cosmos DB. We will meet again in a couple of weeks. Next time, we will be talking about an interesting topic as well from another CSA. Uh, yeah, thanks, RK, for joining us, and thanks everyone for listening in. See you.
Thanks, Aji. Thank you. See you.
Thanks. Bye.